This video will provide an introduction to modeling in data science. By the end of this video, you should know what a model is in data science, how modeling fits into the data science workflow, and what the goals are of modeling in data science. The first question you should ask yourself about modeling is, why is it a part of data science? Models are how we use data to make better decisions. This makes modeling a critical component of the data science workflow. If you remember the data science workflow that we've seen several times in the past, the modeling component is a critical part of the exploration process, along with transforming and visualizing your data. Results of your modeling are going to feed into your decision-making process, first by communicating those results, then using them to inform better decisions, and then finally in evaluating your entire data science workflow. How are you going to use modeling in the data science workflow? First, it helps you understand relationships between variables in your data. We can do this to some degree with visualizations, but modeling is an empirically disciplined approach to actually delving into these relationships. Second, modeling allows you to test hypotheses about relationships in your data. Third, modeling allows you to estimate the strength of those relationships. And fourth, and importantly, modeling allows you to make predictions about the future. Given some information, you're actually able to make predictions about things that you haven't yet observed. So what exactly is modeling? It's the process of constructing and evaluating models. To understand what that means, we really need to know what we mean by a model. Very generally, a model is an approximation of some real-world process or phenomenon. This is a very broad definition, and models can mean different things to different people. A model in medicine or epidemiology is very different from a model in economics. So what are models to data scientists? These are tools that leverage data. They're going to take a set of inputs, some input data, and they're going to estimate how those inputs influence or are related to some outcome. What this means is every model in data science is able to create a prediction of some outcome for every set of inputs. I want to emphasize these models are an approximation of the real world. In general, no model is perfect, and every model is going to have some kind of error in its predictions. Of course, you want to minimize these errors, but not all errors are the same. You may care about one type of error more than another. So an important component of this modeling process is characterizing the types and the magnitudes of errors that you expect from a model. But just to think about this in graphical form, a model is going to take some kind of input data, usually from many different sources, and combine that information in such a way as to make a prediction about some other outcome that you're interested in. Despite the way that I've drawn it here, not every model is a black box. Some models you can open up, look inside, and see how each of these inputs are influencing the prediction. Other models are much more opaque, where it's very difficult, even after you have developed a model, to actually tease out the relationship between a particular input and how it influences the predictions. In essence, models are a function that takes some input data and return a prediction as the output. This section of the course is going to cover the entire modeling process. Part of this are assumptions or decisions that you as a data scientist are going to have to make. Some of these are, how do you think particular inputs are going to influence the outcome? This can be thought of the functional form of the relationship between your inputs and the output. You might need to decide which inputs are important. This is a variable selection problem, which is very important in the data science world. And then lastly, you're going to need to decide what constitutes a good model. This is embodied in the loss function. We'll cover each of these components down the road. It's also good to understand the terminology we use in modeling. Economists frequently refer to the inputs of their models as independent variables or covariates, and the outputs of their models as the dependent variable or the outcome. Computer scientists generally use a completely different but equivalent terminology where they term the inputs to their models as features and the outputs of their models as labels. I'll frequently use the feature label terminology, but understand that these are interchangeable with the economics terminology and other terminologies used in other disciplines.